Hi everyone, today we're going to work through the review problems for the Unit 6 Test 2 over rational functions that's happening tomorrow. So the first question says use long division to divide. So when I divide using long division, I'm going to do it over here because there's more vertical space. I have 3m cubed, then I want the m squared term, which is 13m squared, and then the m term, minus 35m, and then plus the constant, 65. If I were missing any of these terms, m cubed, m squared, m, and the constant, I would have put a 0 term in there. 3m plus 8 is what I'm dividing by. When I go through my long division steps, they are divide, multiply, subtract, and bring down. And when I divide, I just divide the first terms in my polynomials. So 3m cubed divided by 3m is m squared. So m squared will go above the m squared term. When I multiply, I distribute. M squared times 3m is 3m cubed. M squared times 8 is plus 8m squared. When I subtract, I draw the line, I change both signs. The first terms cancel out, and negative 13m squared minus 8 more m squareds is negative 21m squareds. And I bring down my minus 35m. I start the process over. So again, dividing just the first terms, negative 21m squared divided by 3m, 1, there we go. Negative 21 over 3 simplifies to negative 7, and m squared over m is m. So minus 7m lines up with my other m term. I multiply with distribution. Negative 7m times 3m is negative 21m squared. Negative 7m times 8 is negative 56m. I draw the line, I change both signs. These cancel out, and when I put these two together, it's like 56 minus 35. So if I do 56 minus 35, I get 21m. I bring down my plus 65. And I start the process over again. Dividing only the first terms, 21m over 3m is simply 7, so plus 7. 7 times 3m is 21m. 7 times 8 is 56. I draw the line. I change both signs. First terms cancel out. 65 minus 56 is 9, so that's my remainder. So when I write my answer, my polynomial answer is m squared minus 7m plus 7, and then plus my remainder of 9 over what I'm dividing by, which was 3m plus 8. All right, let's move on to number 2, using synthetic division to divide. So for synthetic division, I'm going to write the coefficients of my polynomial that I'm dividing out in a row. So this is 1x cubed, 4x squared, negative 54x, and 60. My r value up here is the opposite of my constant here that I'm dividing by. So if x plus 10, that means minus 10 is my r value. I'm going to bring down my first coefficient, and that's what I'm going to use to multiply by the r value. 1 times negative 10 is negative 10. And then I add down. 4 plus negative 10 is negative 6. Multiplying, negative 6 times negative 10 is 60. Adding down, negative 54 plus 60 is 6. Multiplying, 6 times negative 10 is negative 60. Adding down, 60 plus negative 60 is 0. This is my remainder. And when I write my answer, these are my coefficients of the answer, and I give them x's with 1 less power than what I started with. So this would be 1x squared, because that's 1 less power than the x cubed. And then minus 6x, and then plus 6 with no remainder. So here is my answer. Okay, moving down to number 3 and 4, which share the same instructions. It says find the following. Remember to write the ordered pair for any whole. If no whole, write none. If no intercepts, write none. If no asymptotes, write none. So on number 3, first thing I want to do is find the domain. Well, the domain of all rational functions is all real numbers except any x values that you take out. And remember that you take out x values that make the denominator 0. So x minus 4, we don't want it to be 0. So if I solve my little mini equation, x cannot have a value of 0 plus 4, which is 4. Well, it turns out that x cannot equal 4 in the domain because there is a vertical asymptote at x equals 4. If you remember from our asymptote notes, you set the denominator equal to 0, you solve, and that's where the vertical asymptote is. So that's why it's taken out of the domain. Now, for holes, we're looking for common factors on top and bottom that cancel out. There was no factoring to do here and no canceling to do, so for holes we're going to write none. There were no canceled out common factors. For the horizontal asymptote, I want to think back to my notes and I want to think about the degree of the numerator and the denominator. This has no x up here, so this is degree 0. It's like x to the power of 0. This is x to the power of 1. And if the degree in the denominator is bigger than the degree in the numerator, then the horizontal asymptote is y equals 0. The range, if you want to visualize what's happening with this rational function, the range is all the y values from the bottom to the top, and in a rational function, I'm going to go ahead and sketch the parent function here. In a rational function, there's no bottom boundary and no top boundary, but there might be a horizontal asymptote, so you want to make sure you take out whatever y value you have for a horizontal asymptote. So the range from bottom to top is all real numbers, except y can't be equal to 0 because there's a horizontal asymptote there. Now let's talk about the x-intercept and the y-intercept. In order to find the x-intercept, we remember that we're supposed to set the numerator equal to 0. Well, if I set 1 equal to 0, that doesn't really tell me anything, so for the x-intercept I'm going to write none, which kind of makes sense because there is an asymptote along the x-axis, so there can't be an x-intercept. For the y-intercept, we're going to substitute 0 for x everywhere we see x. So f of 0 equals 1 over 0 minus 4. That's negative 1/4. And that's my y-intercept. So now I'm going to look at number 4. Number 4, there is some factoring that can be done. I can take out a GCF of negative 2 in the numerator. That will leave x minus 3. The x plus 2 remains on the bottom. There's no common factors to cancel out, which means there's no holes. The domain is all real numbers, except any x values that make the denominator 0. So, x plus 2 cannot be 0. So x cannot be negative 2 in my domain. Well, x can't be negative 2 in the domain because that's what makes the denominator 0, so there is a vertical asymptote at x equals negative 2. Usually these two go together. The only time that there is an exception is when there is also a hole, and that x value also gets taken out of the domain. Now let's look at the horizontal asymptote. The horizontal asymptote comes from the degrees of the numerator and denominator. The degree of the numerator is 1. The degree of the denominator is 1. In that situation, when the degrees are the same, when the degrees are the same, your horizontal asymptote is y equals the ratio of the terms with the biggest exponents. The ratio of the coefficients of the terms with the biggest exponents. So if we have x here, x to the power of 1, the coefficient is negative 2, so that goes on top. Here's our biggest term with an exponent here, and its coefficient is 1. So negative 2 over 1 is negative 2, and that's the horizontal asymptote. Remember, the range is all real numbers except any y value that you had a horizontal asymptote at, so y cannot be equal to negative 2. For the x-intercept, we want to set the numerator equal to 0. Truthfully, we want to set the function equal to 0, but we know that happens in a fraction when the numerator is 0. So if I set negative 2 times x minus 3 equal to 0, I just need to set each factor equal to 0 and solve. Well, negative 2 is not equal to 0. That gives me no information. But here, x minus 3 equals 0 gives me an x value of 3. So there's my x-intercept x value. For the y-intercept, I want to substitute 0 for x everywhere I see it. So f of 0 equals, I can use either function. I'll use the first one, negative 2 times 0 plus 6 over 0 plus 2. Well, negative 2 times 0 is 0, plus 6 is 6, 0 plus 2 is 2, and 6 divided by 2 is 3. So there's my y-intercept. Let's move to the next page. Solving the rational equation. You must show all of your work. This is a throwback problem. And it sort of seems here that it's missing something, and I believe it is missing something. So, for people who haven't watched this video, I'm sure that they'll probably end up skipping this problem, but if you're watching this video right now, let's go ahead and fill in a 24 here, because I think that's what was meant to be there. So, I'm going to factor all of the denominators. Remember, this is an older topic, so our goal is going to be, in order to solve, to cancel out all of the fractions. So we're going to find the LCD, and then we're going to multiply every term by the LCD. So here, two numbers that multiply to be 24 and add to be negative 10 would be 4 and 6, but they both need to be negative. So this would be v minus 4 and v minus 6. Same thing, v minus 6. And this is already v minus 4. So the LCD is what they all have in common, which is v minus 4, and what they don't have in common, which is v minus 6. So I'm going to multiply all terms by v minus 4 and v minus 6. So, in my first term, if I cover this up, I no longer have this trinomial because we factored it into the v minus 4 and v minus 6. So if I cancel out common factors, the v minus 4's cancel out, the v minus 6's cancel out, and the 2 remains. If I look at my second factor, again, this no longer exists because we factored it. The v minus 4's and the v minus 6's cancel out, so all that remains is the 1. And then in this last factor, the v minus 4's cancel out, and what's left is 4 times v minus 6. So I'm going to distribute right here. 4 times v is 4v. 4 times minus 6 is minus 24. And now I have a much simpler equation that I can solve for v. So I'm going to combine my like terms. 2 and negative 24 is negative 23. Keep in mind that I didn't do like minus 1 and minus 1. We only do inverse operations when we're moving things to the other side of the equal sign. If they're on the same side, we just combine them. 1 minus 24 is negative 23. So now I'm going to move this to the other side. So now I use my inverse operations. So 23 plus 2 is 25. And if I divide by 4, v equals 25 over 4. So that's my solution to the rational equation. I do want to make sure that it doesn't give me a denominator of 0, so I'm going to check both of these. If I put 25 over 4 minus 4, that's not going to be equal to 0 because this doesn't have a value of 4. And if I put 25 over 4 minus 6 not equal to 0, well, this is going to be okay because this is not 6. V can't be 4 and V can't be 6. So V can be 25 over 4. Let's move to number 6. Takes up a lot of space. Number 6 says, given that f of x equals negative 2x squared plus 2 over x squared plus 4x plus 3, identify the following, and show specific points on the graph. So in order to finish the problem, I need to find all the pieces, but then I also need to graph. So my domain, I need to find by first factoring everything. So if I factor the numerator, I can take out a GCF of -2. I'm left with x squared minus 1. That's a difference of squares, so this can be factored again to be -2 times x plus 1 times x minus 1. The denominator, I need two numbers that multiply to be 3 but add to be 4. Well, 3 times 1 is 3, and 3 plus 1 is 4. So x plus 3 and x plus 1. So let me put this together. So x equals -4 times x plus 1 over x plus 3. Oops, I'm sorry. There we go. I notice that there are common factors of x plus 1. So those can be canceled out. That means there's a whole. There's a whole where x plus 1 is equal to 0. So x equals -1. If I substitute that -1 back into the function, this is where I'm finding the whole, by the way. This is the work for the whole. I'm going to find that f of -1 equals -2 times -1 minus 1 over -1 plus 3. -1 minus 1 is -2. -2 times -2 is 4. -1 plus 3 is 2. So the f value, the function value, is 2. And that's how you find the whole. The domain is all real numbers except the x values that will create a denominator of 0. So here, the x value that creates a denominator of 0 is -1. We already found the whole there. So x can't be equal to -1. The x also cannot be equal to what makes this 0, which would be -3. If I set x plus 3 equal to 0 and I get -3, that's where the vertical asymptote is. That's why it's been taken out of the domain. The horizontal asymptote occurs when you compare the degrees of the numerator and the denominator. So when I compare the degrees of the numerator and the denominator, I notice that this degree is 1 and this degree is 1. They have the same degree, which means you want to use the coefficients and create the ratio of the coefficients. So the coefficient of x is -2. The coefficient of x is 1. So this is y equals -2 for the horizontal asymptote. I'm going to skip the intercepts for right now because since I know my horizontal asymptote is at y equals -2, I'm going to write my range, which is all real numbers except the horizontal asymptote. Y can't be equal to -2. Now for the intercepts. For the intercepts, and I'll probably do that work down here on the bottom, for the intercepts, I need to set the function equal to 0, which means I need to set the numerator equal to 0. So I'm going to take this numerator for my X-intercept. I'm going to set it equal to 0. In order to solve, I'm going to set each individual factor equal to 0. Well, -2 doesn't equal 0. That tells me nothing. But when x minus 1 is 0, x has a value of 1. So there's my X-intercept, x value. For the Y-intercept, I need to set x equal to 0 everywhere I see x. So I'm going to do that down here. F of 0 equals -2 times 0 minus 1 over 0 plus 3. 0 minus 1 is negative 1. Negative 2 times negative 1 is 2. 0 plus 3 is 3. So my y-intercept y value is 2/3. So now I'm going to graph all of the pieces. The vertical asymptote is at x equals negative 3. So 1, 2, 3, here it is. Asymptotes are typically depicted with dotted lines or dashed lines. The hole is at negative 1, 2. So negative 1, 2, there's a hole here. The horizontal asymptote is at y equals negative 2. The x-intercept is at the point 1, 0. The y-intercept is at the point 0, 2/3. This is looking good. It looks like I can connect. My range is all the y values except y can't be equal to negative 2. And my domain is all the x values except x cannot be equal to negative 1 and it cannot be equal to negative 3, which is good. So I can go ahead and fill in my hyperbola, making sure I don't put a line through that hole, but I do connect these. And then sketching that part of my hyperbola as well. All right, let's move on to number 7. Number 7, I have a graph. I'd like to fill in the pieces that I know. So first I want the x-intercept. The x-intercept crosses the x-axis. That's right here at the ordered pair 2, 0. The y-intercept is the place on the graph that crosses the y-axis, so that's right here, 0, 1. The vertical asymptote is the vertical line where it looks like the graph starts approaching but never touches, so right here. That goes through an x value of negative 2. The horizontal asymptote is the horizontal line where it looks like the graph is approaching but never touches. So that's going through a y value of negative 1. The holes, well, as I'm looking, it doesn't seem like I have any holes, so I'm going to put none. The domain is all real numbers except negative 2. So x can't be equal to negative 2. And the range is all real numbers except y can't be equal to negative 1. When I write the function, I start out with f of x equals, and I consider my vertical asymptote, which typically comes from the denominator. If x equals negative 2 is the vertical asymptote, well then that means x plus 2 was the denominator. If the horizontal asymptote is negative 1, that means that it was a ratio of the coefficients of the numerator and the denominator, and they probably had the same degree. And in order to find the x-intercept, this 2, we needed to set the numerator equal to 0. So if x equals 2 was my x-intercept x value, and you needed to set the numerator equal to 0, well, then this probably was x minus 2. However, it needs a negative out in front so that it matches our horizontal asymptote. So this was probably negative x plus 2 equals 0. Move down to the next question. It says, write the equation of the rational function, state the characteristics of each function. This problem, I'd like for you to ignore the H, the K, and the A, because that's part of a different type of problem that we haven't seen yet, and I forgot to take those off of the review. However, we can identify the asymptotes in the domain and range. So the horizontal asymptote is right here. It's going through a y value of -4. The vertical asymptote is right here. It's going through an x value of -3. The domain is all real numbers, except x can't be equal to -3, because there's an asymptote there. The range is all real numbers, except y can't be equal to the horizontal asymptote, which is -4. And we're going to skip the rational function part as well. Last question simply asks you to find the asymptotes of the rational function below. So the vertical asymptote looks like it's right here. Notice that this part doesn't quite touch and this part doesn't quite touch. This is going through an x value of 2. And the horizontal asymptote can start where the graph really starts approaching that piece, that horizontal line. It never touches. So that's going through a y value of 1. So there is your review worked out. I want to caution you in being too obsessed with trying to find this piece, because this piece is something that you're really not going to see very elaborated on in your test. But all of the other pieces are what we've been talking about with our rational function conversations. So don't worry so much about this if you were thrown off, but all the other pieces you should be able to get from your graph. So good luck studying and good luck on your test.